Hello everyone, welcome back to Logic Binder. In today's video, we'll learn about the structural representation of finite automata. The finite automata is a mathematical model of computation which is used to recognize the patterns in languages. Given the input as a sequence of symbols, the automata recognize the input as a patterns. The finite automata process the input through the following components. It contains three components: input tape, read head, and finite control. The input tape is nothing but a horizontal tape which processes the input sequence of symbols. The symbols will be processed through the read head pointed from finite control to the input tape. The read head will read the input one at a time from left to right and process the entire input string. And the finite control is just like a main unit of a finite automata which stores the set of transition states. The current state will read the first input and process through the entire number of transition states and reaches the end of a string upon processing the input string. Considering the block diagram of a finite automata, let us discuss the first component, which is an input tape. The finite automata reads the input symbols onto the input tape and processes the symbols from left to right in sequence with the two end markers C as well as $. The end marker C indicates that the automata is ready to process the input symbols from left to right. And the end marker $ indicates the end of input symbols. It means that the string is already processed, reaching the acceptance state or a final state of a machine. And the second component, which is a read head. The read head is pointed from the initial state or a start state of a machine or an automata, which is always denoted with Q0. So, from the current state or initial state Q0, the read head is pointed towards the first symbol of a input string, which is A. Q0, upon processing the first symbol A, so this is a data flow from the state Q0. Upon reading an input A, it is reaching the state Q1. Similarly, the read head is pointed towards one position right and the next symbol to be pointed is B. So from the state Q1, the input processed is B and it will move towards the transition state Q2. In the similar way, from left to right, the read head will be pointed towards all the input strings and it will process the last symbol K, reaching the final state capital F. And automatically the read head will be moving towards a $ symbol such that whenever the read head points towards the end marker $, it means that there is no input symbol which is meant for processing in a finite automata, such that F will be considered as a final state. Here we have seen that the automata indicates the processing of input string through the input tape with the two end markers C as well as $ symbols, where C indicates the start of an input string and $ indicates the end of a input string, such that the finite control possesses the transition states and reads the input from initial state towards the final state, such that the string is completely processed. Mathematical representation of finite automata or finite state machine. The finite automata is denoted with the phi tuple Q, sigma, delta, Q0 and F, where Q is a finite non-empty set of a transition states. Here the term finite indicates that the finite automata, upon reading an input from the input tape, will automatically create a corresponding number of memory cells to process the input. Thus, the transition states are based upon the input that is being processed through the machine. And the next element is a input alphabet. The input alphabet is nothing but the number of input characters or a symbol which are being processed as a string to the finite automata. And the next element is delta. Delta is a transition function mapping from transition state Q and the input alphabet sigma deriving a new state which is a Q. Nothing but the transition function is a cross product of Q and sigma to derive a new state Q. It means that the finite automata from one state upon reading an input alphabet will configure into the next state. And the next element of a finite automata is Q0. Q0 is a initial state where the machine will ready to process a input string. And the next element is a final state denoted with a capital F. Here we indicate that F is subset or equal to capital Q. It means that in the finite state machine, depending upon the inputs that we are processing, there can be possibly one or more number of final states which is belonging to the set of transition states. So thus the finite automata indicates capital F as a final state which is a set of final states. Thus the finite state machine is denoted as the phi tuple Q sigma delta Q0 F. Notations used for representing the finite automata. The finite automata is represented as the transition diagram, transition table, and transition function. Usually we denote the finite automata in terms of three notations. Let us learn the first representation of finite automata, which is a transition diagram. The transition diagram is nothing but a graphical representation of a finite automata where the nodes are considered as a set of transition states and the labeled edges between the nodes are considered as a input symbols of a string. The basic notations of a transition diagram are as given below. First, initial state. Let us consider the initial state as a Q0. Considering the state as a node, the incoming unlabeled edge will be indicating that this state will be the initial state, such that the initial state which is represented as a node will always have the unlabeled edge as a incoming edge. And the final state which is denoted by the capital F. The final state is always represented with a double circle. One circle will be indicating the node and the other circle will be indicating that the state is a final state where the input string will be halting the processing of a string. And the next state is a null state. The null state is also considered as a hang state where the automata will be abnormally terminates the input string. Usually, the hang state or a null state will not be belonging to the set of transition states capital Q. And the next notation is here we consider the node Q1 and the node Q2. In between we have a labeled edge which is labeling with the input A. It means that it is a directed edge from the state Q1 to Q2 such that upon reading an input A, the finite automata will configure its state from Q1 to Q2. Here, we consider the set of transitions between the transition state Q1 with the labeled edge as 1, 2, so on till n and the next state as a Qn such that the directed edge with the label shows that the transition from state Q1 to Qn upon reading an input 1, 2, so on till n. It means that the finite automata from the state Q1 upon reading n number of input alphabets through the intermediate states will reach the state Qn and halts the input processing. Transition function. It is denoted by delta. The transition function is defined as the mapping of transition state and input alphabet. Here, the finite state machine from the current state Q upon reading an input symbol sigma will configure to the next state Q. Consider the examples of transition function denoted by delta, Q on input A is equal to P. It means that the finite automata from the transition state Q upon reading an input symbol A will change its state to P. Delta P comma B is equal to P. It means that the finite automata from the transition state P upon reading an input symbol B will remain in the same state P. Here P comma Q are the transition states, whereas A comma B are input symbols. Next, transition table. The transition table is nothing but a tabular or matrix representation of a transitions or changes occurred in a finite automata. Here, we consider the transition states as a rows and the input symbols as a columns and the entries as the next states or a change in a state. Let us consider the following example. In this transition table, we observe that the transition states are considered as a rows and the input symbols are considered as a columns, and the entries of a transition table or a cells are observed as a next state or a change in a state. Now let us examine the transition table. Here the unlabeled incoming arrow denotes that Q0 is an initial state and Q1 is a intermediate state, and the circle indicates that Q2 is a final state. Here Q0, the initial state, upon reading an input symbol A is going to the next state Q1. Let us look at the transition diagram here. The initial state, which is denoted with the incoming unlabeled arrow, Q0, on reading an input as A is moving to the state Q1. So here the entry in the table is Q0 on reading an input symbol A will move to the next state Q1. Similarly, Q0 upon reading an input symbol B is remaining in a same state Q0. Let us examine the transition diagram. Q0 upon reading an input symbol B is remaining in a same state Q0. Thus, the next state Q1 upon reading an input symbol A is moving to the state Q2. So in the transition diagram, Q1 upon reading an input symbol A is going to the transition state Q2, which is a final state. Similarly, Q1 upon reading an input symbol B is remaining in a same state Q1. So here the transition state Q1 on reading an input symbol B is remaining in a same state Q1. And the next transition state Q2 upon reading an input symbol A is moving to the state Q0. Observe here the final state Q2 upon reading an input symbol A is moving to the transition state Q0, and upon reading an input symbol B is remaining in a same state Q2. Q2 upon reading an input symbol B is remaining in a same state Q2. Thus, we consider the three notations of the inputs that are processed through the finite state machine, such as the transition diagram, transition tables, as well as transition functions. For the corresponding example, let us examine few transition functions. Delta, the corresponding transition state Q0 on input A is going to the next state Q1. So the entries of a table will be examined in terms of transition function. Delta Q0 on input A is moving to the corresponding transition state Q1. Similarly, from the transition state Q0 upon reading an input symbol B is remaining to the same transition state Q0.